Greetings, my young math Padawans. This is lesson 4.4, factoring polynomials. More of the same, part 2. Here are the steps for factoring a polynomial. Please make sure you go back and reference these. In this lesson, we're going to be focusing on what happens if we have 4 terms, and we're going to talk about this thing called factoring by grouping. So let's look at an example problem. So here's x to the third minus 2x squared minus 9x plus 18. You'll notice that there are 4 terms in this problem. 1, 2, 3, 4. Because of this, I'm going to look, of course, for a GCF always, but you'll notice that there's not a GCF. You'll notice that it's like, well, these first 2 terms or even 3 terms, something could be divided out. And these last 2, we could divide something out, but there's nothing that we can divide into all 4 terms. So in this problem, there isn't a GCF. So instead, what I'm going to do is I'm going to go through this process called factoring by grouping. Factoring by grouping looks like this. I'm going to divide this polynomial into 2 groups. There's the first group, and here is the second group. And what I'm going to do is I'm going to look at each group, and in each group, I'm going to pull out the GCF of each group. So first, in this red group, what can I pull out of x squared and x to the third and negative 2x squared? The answer is an x squared term. I can pull that out, and if I do, I'll be left with an x minus 2 in parentheses. What about these next 2 terms? What can I divide into both negative 9x and 18? And the answer is, of course, negative 9. And here's why I picked negative 9, because look what's going to happen. If I divide out a negative 9 out of that, I'll have x minus 2 left over in the parentheses. And what you should notice that in both of these parentheses, I have exactly the same thing, x minus 2. And I should. If, for example, I would have gone over in this group and I would have just factored out a 9 instead of the negative 9, right, I would have had negative x plus 2. And my 2 parentheses would not have matched. If that ever happens to you, it's not a factoring by grouping problem, or you've done something wrong. So you should make sure that if you pull out the negative. That's the bottom line here of the story. So now when I continue to factor this, what you should see that they have these x minus 2 in common. So I'm going to write that out front, x minus 2. What they have in common, I'm going to write it out front. And then I'll put the leftover stuff inside the parentheses. So I have x minus 2 times x squared minus 9. I've pulled out that, I've done the factoring by grouping. I've looked at the 2 separate groups, and I've pulled out what they have in common, and I put the leftover stuff in that parenthesis. Now, I simply make sure that what I have is factored completely. So, of course, that x minus 2 is factored completely, but check this out. Look at this, x squared minus 9. Well, that's the difference of 2 perfect squares. So I'm going to continue factoring that, come up with x minus 3 times x plus 3. This is now factored completely, and I can't go anymore. Let's take a look at another example together. Same idea. I will look at all 4 of these terms, and I'll say, is there anything I can divide into all 4 of them? No, there's not. So what I'm going to do is, again, I'll divide it into 2 groups. I have this first group, and I have this second group, and I'm going to look, what do they have in common? See if you can do it. See if you can write out that first step. Pause the video if you need to. But if you look at the first 2, the ones that I've underlined in green, you should see that an n squared can be pulled out. And I'm left with an n plus 5. And in the second set, I can pull out the negative 4. And I'm left with n plus 5. Did you notice? Did you notice how the 2 parentheses match? The n plus 5s match. So I can write them one time. And then I can put the leftover stuff in that second parenthesis. And now if you look, the n squared minus 4, I ask myself, can I factor that further? If I can, I want to factor it. If I can't, I can be done the problem. But in this case, oops, it's an n. Let me back up. It's an n minus 2 times an n plus 2. And that is, in fact, now factored completely. So at this point, I'd like you to try these 3 problems. See if you can factor these completely. These are factoring by grouping problems, but give these a try and pause the video. And then here in a minute, we'll go over the answers to these problems. So go ahead, pause the video right now. Try these 3 on your own. All right, n to the third minus 3n squared plus 9n minus 27. Let's go ahead and factor that. We'll split that into two groups. Let's see here. We got n squared. That would be n minus 3. What about the second one? I can factor out a positive 9, and I get n minus 3. Do you see what they have in common, that n minus 3? I'll write it once. And then I'm left with n squared plus 9, which will be left over, and n squared plus 9 cannot be factored anymore. That is the sum of perfect squares, so that is in fact finished at this point. Number 4, same idea. And x squared can be pulled out of those first two terms. And a negative 1 can be pulled out of those second two terms. You'll see that I have the x plus 4s that match. Then I have x squared minus 1 left over, which that can be factored further, which I will do, and end up with a final answer of x plus 4 times x minus 1 times x plus 1. One more here. Let's hear. What do these first two have in common? Y squared. That'll leave me with 3y plus 1. What about the second two? Let's see here. A 3. That'll leave me with the 3y plus 1. These two parentheses match as they should. So I get 3y plus 1 times y squared plus 3. That will in fact be the final answer. I can't factor it anymore. For these remaining problems, we're going to look at equations that are quadratic-like equations. What do I mean by that? I mean, these are quantities that are kind of quadratic, but not really, because they'll be raised to different powers. And there's different things we got to look at. And really, it's about taking everything that we've done with factoring so far and applying it to things of different exponents. So, for example, every single one of these is going to be a little different than the one we do previously. So 16x to the 4th minus 81. This has two terms. And in this particular problem, it's about recognizing the shortcut rule that may be there, that you can see. And it's about looking at that and knowing your rules of exponents enough and recognizing things enough to know that 16x to the 4th can be rewritten as 4x squared squared. And this 81, that is 9 squared. So what you end up with in this problem is you end up with the difference of two perfect squares. I think we're very used to seeing not an x squared in that particular term, instead getting rid of the squared when we look at that. But that does not necessarily have to be the case. It's kind of why we use the a and the b when we're looking at that perfect square rule. So once we have it written as a squared minus b squared, like I do here, right? Here's the a, x squared minus 4x squared. And here's the b, 9. And once we have it written like that, we can spread this out and we can write it as a minus b times a plus b. So that's 4x squared minus 9 and 4x squared plus 9. And that's factored. That uses the shortcut rule. I just now need to make sure that I've factored this down completely. In the second parentheses, 4x squared plus 9, that is a sum of two perfect squares. But look here, 4x squared minus 9. If you look at that, you can rewrite 4x squared as 2x, that quantity squared, minus 3 squared. That's different. So what I can do here with this problem is I can keep factoring. I can rewrite this first parenthesis as 2x minus 3 times 2x plus 3. Now the second parenthesis is already factored completely and I can't go any further than that. And I'm done with this problem. So it's 2x minus 3 times 2x plus 3 times 4x squared plus 9. Folks, I know this can be a little bit intimidating when you're looking at these problems, and unfortunately, other than me showing you a bunch of different examples, I can't really help you see the quadratic-like equation. That's something that you're just going to have to train your brain to look for and to recognize when in fact you do see it. Let's go on to number 2. 3p to the 8th plus 15p to the 5th plus 18p squared. Well, the first thing I always do is I always look for a GCF, and in this problem I do have one. In this problem I have a GCF of 3p squared, so I'm going to factor that out. That'll leave me with p to the 6th plus 5p to the 3rd plus 6. Now, this second parenthesis, This 3p squared we're going to ignore for a while, but this p to the 6th plus 5p to the 3rd plus 6p, that's a quadratic-like equation. Let me show you what I mean. I can rewrite this p to the 6th as p to the 3rd squared. And then I'd have plus 5p to the 3rd plus 6. And when I write that out in that way, and you think about it, all I'm really doing is figuring out the pair of numbers that multiplies together to give me 6 and adds together to give me 5, just like I did with the whole Xbox thing. As a matter of fact, I can show you this with Xbox. We can put the 6 here, we can put the 5 here, we can come up with those numbers of 2 and 3, and then we can go over here to the box. And of course, in the box, I will put p to the 6th, and I'll put 6 here. And then I'll put this 2 and 3, I'll do 2, and that would have to be p to the 3rd because that's the middle term, and then 3p to the 3rd. And what I could do is I could look for the GCF of each one of these rows and each one of these columns. And I could figure out how to factor that down. And what you'll see is that factors down to give you p to the 3rd plus 3 and p to the 3rd plus 2. Don't forget about that GCF of 3p squared that you had. Now, I don't necessarily think it's necessary for you to do this like Xbox thing in the middle, unless it really helps you to see it. Because if you look, all I'm doing is I'm still figuring out that number that multiplies together to give me 6 and adds together to give me 5, and that was 2 and 3, which are right there. Since there's no leading coefficient here, I didn't need to worry necessarily about doing the Xbox. You're just going to have to be on the lookout for these problems and see when they pop up. Why don't you try a couple of them? Now, keep in mind, all 4 of these you may do slightly different than the last. So try them out, see what you come up with, see how you do, and of course, we will go over the solutions here momentarily. For this problem, you should have seen the difference of 2 perfect squares. Man, that's hard to see sometimes, but that's 25x to the 4th squared minus 16 squared. Now, using a calculator might help you out with that. So we can rewrite this as 25x to the 4th minus 16 and 25x to the 4th plus 16. The second parenthesis, that's pretty much done. We can't factor that down anymore. But with this one, again, you should see that as the difference of 2 perfect squares again. So we're going to factor that more. It's 5x squared minus 4 and 5x squared plus 4. Oops, x squared plus 4. And then, of course, that second parenthesis you can't do anything with anymore. This would be my final answer. The next problem, 2x to the 13th plus 10x to the 9th plus 8x to the 5th. I'll pull out the GCF, which is 2x to the 5th. What am I left with? X to the 8th plus 5x to the 4th plus 4. And I'm looking for that pair of numbers that multiplies together to give me 4 and adds together to give me 5. And if I did it correctly, I should have x to the 4th plus 4 and x to the 4th plus 1. And I am, in fact, done factoring that expression. Moving forward, 4 terms. Okay, first thing, GCF. Did you pull it out? 3x squared. If I do that, I have x to the 6th minus 9x to the 4th, 16x squared plus 144. And now I can factor by grouping. I'll look at these 2 terms, figure out what they have in common. That's an x to the 4th. I'll look at these 2 terms and say, what do they have in common? That's a 16. And I got x squared minus 9 left over. Now, got to be really careful. That's all in a big set of parentheses, and you still have that 3x squared out front. So I got that 3x squared in my first parenthesis. I'll have x squared minus 9, and then I have that x to the 4th minus 16. Now, look really closely at this because there's more factoring to do. Check it out. This x squared minus 9 is, in fact, x minus 3 times x plus 3. Don't forget about this 3x squared that you still have in the front. And then let's look closer at this x to the 4th minus 16. But look at it closer. X to the 4th can be written as x squared squared minus 4 squared. Hey, that's the difference of 2 perfect squares again. Okay, so let's keep going. We're going to keep going here. X minus 3 times x plus 3. And then what do we have? We'd have x squared minus 4 times x squared plus 4. All right, I got to be done now. But wait, no, I'm not. Check out this. This right here, x squared minus 4, can be factored more. We can factor that down more. That's the difference of two perfect squares. That's x minus 2 times x plus 2. All right, let me write all this other stuff back down here. We have the x squared plus 4. We got the x plus 3. We have the x minus 3. And we got the 3x squared. I have to be done now. And yes, actually right now, I am done, and I have factored that thing completely. Talk about overtime. Wow, what a problem. That's a good one. Let's keep going. Let's go do another one. One more. All right, 3x to the 7th minus 27x to the 5th minus 24x to the 4th plus 216x squared. Looks a lot like the last problem, but this one we'll find is very different. So I'm going to pull out the GCF just like I did in the last problem. And, well, looky, it's actually the same thing, 3x squared. So that'll give me x to the 5th minus 9x to the 3rd minus 8x squared plus 72. Okay, now factor by grouping again. So we'll look at these first two terms. Let's see here, what can I pull out? And x to the 3rd, what am I left with? X squared minus 9. What about the next two terms? What can I pull out there? How about a negative 8? And then what am I left with? X squared minus 9. Okay, big parentheses, put the 3x squared in front. All right, got the 3x squared. Then we'll have the x to the 3rd minus 8. That's stuff they have in common. And then the two things that match, that x squared minus 9. I'm going to keep factoring because I can. So I got the 3x squared. I got this x to the 3rd minus 8. That's that perfect cube rule. So if you don't know what that is, make sure you go look that up again. Make sure you know what that looks like. It's a perfect cube rule. And then we have this x squared minus 9, which we can factor down to be x minus 3 times x plus 3. Whew. These problems are great because there's so many different factoring rules that you can do, and you got to know when to stop, and you got to know when to keep going. You'll get there with practice. This definitely takes a lot of practice until you get really used to this. And fear not, you know you will have some practice. All right, folks, if you have questions, make sure you ask them, get some help with this, because I have a feeling you're going to need it. See you soon.